On number 24, we are to state how many complex and real zeros the function has. Well, you should start with the degree, and the degree of our function is 4, which tells us that we have 4 complex zeros, and then you look at your graph to determine how many of them are real, and we see 2. So 2 of them are real. On to number 24. I'm sorry, number 28. On number 28, our directions say, find all of the zeros and write a linear factorization. From our picture, from our graph, we see that we have a 0 at 3. So let's go ahead and start with 3 and go from there. So we'll have 3, and all of our powers of x are there, so we don't have to worry about having any placeholders here. So 0, negative 10, 44, and negative 69. 1 down, 3 up is negative 7. 3 times negative 7 is negative 21. That gives us 23 when we add. Multiply up, we get 69, which confirms what our graph told us, and that is that 3 is a 0. Well, our synthetic division tells us that x squared minus 7x plus 23 is a factor. So let's go to some scratch paper to figure out what zeros we have with that quadratic, because it's clearly not factorable. So we'll rewrite it here for our reference and use the quadratic formula, which says negative b, and our b is negative 7, so that's going to be positive 7, plus or minus the square root of b squared, which is 49, minus 4 from the quadratic formula, times a, which is 1, times c, which is 23, all over 2, because the denominator of the quadratic formula is 2a, but our a is 1. So then we just clean up from here, and we get 7 over 2, plus or minus, and then we've got to clean up what's inside the square root there, our discriminant, and we have 49 minus 92, which gives us 43 negative. So inside the square root we have negative 43 over 2, and then I can clean up that negative square root by pulling out I, and that is my 2 zeros. So now we're going to put that into our linear factorization. So we have f of x equals, our first linear factor was x minus 3 from the 3 we got from our synthetic division, and then we have x minus 7/2 minus I on the square root of 43 over 2 times x minus 7/2 plus I on the square root of 43 over 2. And in the back of the book you probably won't see that answer, because typically we eliminate fractions, which we could accomplish by multiplying each of these factors by 2 to kill off those denominators. So our final answer then, we're going to have to make up for the fact that we brought those 2 factors of 2 in by putting a 1/4 out front, sort of undoing the multiplication that we did. And then that gives us, when we distribute the 2, 2x minus 7 minus I on the square root of 43 times 2x minus 7 minus I on the square root of 43. And that's number 28. Let's look at number 30 as the final example for this video. And our directions here, same set, says find all the zeros and write a linear factorization of the function. Well, we see a fraction there, and we see a -2. So let's start with our factors, or our candidates for factor, or zeros, by doing our plus or minus p over q, which gives us plus or minus 1 and 2, and then our leading coefficient is 3, so we're going to have plus or minus 1 over 3. We like a short list that this one's going to make. So that would be plus or minus 1, plus or minus 2, and plus or minus 1/3. That is our only candidates for this problem, which means we got less work to do, especially when we combine it with the fact that we had access to this graph to know that we should start with -2. And not only does our graph tell us where to start, it also tells us what we can eliminate. So we know that the only possible 2 is negative based on our picture, because there it sits. Positive 2 is clearly not crossed. And then we can also cross off both of the plus or minus 1s, because you don't see those in the picture. So that narrows us down to plus or minus 1/3, and by our picture it appears that it's going to be the negative possibility there as well. So we already know what we're going to use for our synthetic process here. So let's start with -2, and we've got all our powers of x, again with no placeholders needed. So I have 3, 8, 6, 3, and 2. And that's a -2. Everybody else is positive. So then we bring our 3 down, multiply up, add, multiply up, add, multiply up, add, and there's our positive 2 we needed to get 0. So that verified that our first factor will be x plus 2, and then we'll use the last row to take our 1/3 in for synthetic, and so we're going to do positive 1/3, and then take those coefficients from the last line of our last synthetic division. Bring the 3 down. 1/3 of 3 is 1. Add, you get 3. 1/3 of 3 is 1. Add, you get 3. 1/3 of 3 is 1. That gives us 0. And we've got our factorization. So we have f of x equals x plus 2 times x minus 1/3. And we translate that last line into, because we started with a 4th degree, and this one was 3rd degree. This one is quadratic, so we have 3x squared plus 3x plus 3, and that one is screaming at me to take that 3 out, so I could write that as 3 times x squared plus x plus 1. So I've got so far x plus 2, and now I'm going to distribute this 3 back over here because that'll take care of this 1/3, and now we've got 3x minus 1. And then we've got to figure out our factors for x squared plus x plus 1. So we have a little more work to do there. So x squared plus x plus 1, I need to know the zeros because that will tell me what my factors are for my factorization. Using the quadratic formula, x equals -b, our b is 1, plus or minus the square root of b squared, so that's 1 squared, minus 4 from the quadratic formula, times 1, our a, times 1, our c, all over 2a, which is just 2 because a is 1. And we get -1 plus or minus over 2, and we go in here and figure out what's left inside from our discriminant, which is just 1 squared is 1, minus 4 times 1 times 1, so that's 1 minus 4, which is -3. So we have -1 over 2, plus or minus I on the square root of 3. So that gives us, as our next two factors, x minus, let's look at those again, 1/2 plus or minus I. So I'm going to have 1/2 minus I on the square root of 3, and x minus 1/2 plus I on the square root of 3. Oh, that's over 2, isn't it? Sorry. let's try that again so my 3 doesn't look so small. So this is over 2, and this is also square root of 3 over 2. And again, to get rid of all these fractions, because the complex numbers are enough to look at, we would come in and multiply each of those factors by 2. So I'm going to multiply the last 2 factors by 2. So I've really just multiplied this problem by 4. So I'm going to make up for that by pulling a 1/4 out front. So we have x plus 2, 3x minus 1, and when I distribute my 2's in, I'm going to have 2x minus 1 minus I on the square root of 3 times x minus 1 plus I on the square root of 3, and I just squeezed that into the screen, and that's it.